I would actually switch to English if that's fine for you, because we have some people who cannot understand German so well or not at all. I have prepared everything in German, so the German-speaking people can still read everything. Everybody else can just follow my voice, basically. So, yeah, I'm Max from TeamViewer. For the few people who don't know TeamViewer, it's a remote access solution to connect from one PC to another, from a Mac, from a Linux PC, from a Windows PC, Android, iOS, all supported. And yeah, basically that's it. It's a German-based company, despite the name sounding more like American, and it exists since 2005, so around about 20 years now. My team is the so-called CI/CD team. We take care of the essential services for R&D, like Bitbucket, Artifactory, GitLab, and Jenkins. And we have around 250 servers in our data center, which are running on Windows, Mac, and Linux. They are not in the cloud. We have like still a traditional data center. I will come back to that later. And yeah, we are basically the service desk for all developers. If they have any problems with these tools, with the build servers, they will come to us. If they need some assistance creating a pipeline in Jenkins, they will come to us. And we also yeah, took over GitLab not so long ago. And of course, our team also plans the infrastructure for the next years. So we are also in contact with finance, with IT, because yeah, in the end, we need to provide the data, and they need to plan it in the budget. And yeah, for all questions that we don't know, and that's a lot, because we have so many different platforms to cover, we have like our domain experts for Android, for iOS, for Linux, and so on. So if people come to us and ask a specific question about a build, we will just tell them, yeah, you can just go to these two people, they are the experts there. So. I'm at TeamViewer since 2015, so quite a while now. In the first 3 years, I worked in IT. Then I switched to CI/CD, which is located in the R&D department. I take mostly care of Linux servers. I can do Windows, I can do macOS, but Linux is like my specialty. And I will do web development in, yes, PHP, JavaScript, and MySQL. I will give you a simple example. Why PHP? Because, yeah, it's not the most obvious choice nowadays. Many years ago, we had something, oh, why is it not showing? Wait a moment. So, now it's showing. Okay, perfect. Many years ago, we had, when I started in IT basically, we had the usual case, people called us and said, okay, I have a problem with my computer, can you come over? And I asked, okay, where are you sitting? Yeah, at the window front. The window front was, imagine this room 2 times, like 50 meters, 100 meters long window, and you had to walk over there, and maybe they would know your face and they would wave at you, and yeah, I'm here. And that was never a good solution. And from time to time, we also had the so-called desk moves. So we had to move one person from one desk to another with their workstation, their screens, and so on. And there were some plans how to organize this by office management, but they were usually on paper or as a PDF, where you would see the plan, like here, with the different numbers of the desks. And they would provide an additional Excel table with the numbers and the names. And you had like puzzle it together and move it around. And I always thought, why is there no easy approach? Because it's basically a database and a card, a map where I just put the data on. And that's where I started my first not my first PHP project, but my first PHP project in the company. I just put it together because I could do some PHP. I was not an expert or anything. And basically, yeah, you have your desks on this map presented by little circles, because it's easier than if you have to rotate it in some rectangular shape. And yeah, you have me sitting there. And this is matched by just putting like the desk number in the Active Directory for the profile, and it will import it automatically. So I showed this to my team lead, and my team lead was like, "Oh, Max, that's quite cool, but you know, we don't develop in IT. Just skip it. We don't need this." He thought it's a waste of time. Of course, I did what all developers do. I followed what my team lead told me and skipped the project. No, I invested the time on the weekends. I just continued with this, and because I was convinced it's a good solution, I shared it with some people in R&D, in marketing, in sales. Everybody was like blown away. "Oh, that's cool. Now we have like a map, and we know where everybody's sitting, and we get in contact with each other much easier." And after half a year, it was like accepted as like the official solution from IT. Yeah. And around that time, and that's why I come back to R&D now, I was asked by a team lead from development, "Max, you did this great tool here from scratch, like front end, back end, everything, even the marketing. So how to say, basically, by convincing the people. Why are you not in development? Did you ever think of joining the R&D department?" And I was like, "No, never thought of that." And that's basically where I switched. I think half a year later. Let's get back to the presentation. And I will show you quickly basically the time from when I started in R&D, the so-called Stone Age, the Middle Ages, and yeah, to the present basically. And some look into the future, because AI should be included in every presentation. I thought everybody would be turned off by this, by the way, and now I figured it out. It's like the common theme for all presentations. So, Stone Age. Yeah, we had many Windows machines at that time, which were very important, like the most important thing on Earth. We had some Mac OS machines. Yeah, they are there, but they are not so important. And we had some Linux machines, and management was convinced, nobody's using Linux. It's like customer base, 1%. Nobody cares about this. Maybe these few developers who want to access from Linux to Windows, so we have it in our portfolio. And of course, everything was automated by us. So we looked on the machines, and we were like doing the automation thing as a human. For Windows, it was quite easy. Yeah, it had a great, big market share. It was basically the standard also in our IT department. They had the Active Directory. They had policies they could enforce. And many services, they just ran on Windows because it was like the common thing, and everybody knew it. I have one colleague, for example, he set up the first Jenkins. It's running on Windows. And all Jenkinses that we set up later were, of course, running on Linux because they were more performant there. And at that time, we also, for example, built Android completely on Windows because, yeah, that's where we started, basically. For macOS, it was a little bit different. Yeah, market share not so high. IT had no means to manage the machines. They had no special tool or whatever. More device management was required at that time. They didn't have anything. And hardware was quite expensive. So our R&D boss basically also was not so convinced if it's really worth it to invest so much money there. You could not virtualize it except on Apple hardware. And we had our TV client, of course, also for macOS, but it was like basically a completely different product than on Windows, with its own interface, everything written in not C++, but of course in Xcode, Swift, and so on. I'm not an expert in all of this. I don't do client development, so yeah. And for Linux, yeah, not so many people were using it. The usual thing was, if we requested a Linux machine from IT, they would give us a blanco deleted machine, which is like completely empty, and tell us, you are the experts, just install it. And we had not many experts in the company for the build servers, for the Linux servers. And the TV client was basically just the Windows client, which was wrapped into Wine to make it run on Linux. So if he wanted to do a release, again, we needed a Windows machine to do the build, and then afterwards a Linux machine to package it into this wine package and make a debian package out of it. Automation was done by humans. We did the monitoring. We installed our servers from scratch. It was like a big Confluence page or SharePoint page at that time, even, yeah. And we had to follow like 30 manual steps in a specific order to install the Windows servers, for example. macOS machines were maintained by the macOS developers because they were the experts there. Linux was working in mysterious ways, and one developer exactly knew how to do it. But whenever we wanted to make a change or ask some question about the system, we had to reach out to this developer. And of course, he would not tell us how he did it. He would just make the change and let us know, OK, it's done now. And after SVN was gone at that time, basically right when I joined, we switched to Bitbucket, basically to Git, and used Bitbucket as a software. And we had one Jenkins master for everything, which was a little bit of a mess because many developers needed to have elevated rights to create jobs, to do certain tasks on Jenkins. So basically everybody had access to everything, like, I don't know, 50 power users, something like that. Not in a good shape. So, the Middle Ages. Windows was still important. We had Mac, which was somehow people would buy it. So the management decided, yeah, it's maybe not super important, but important now. And on Linux, yeah, the first developers figured out, oh, containers are really, really cool. Maybe we should do most of our stuff in containers. And we had like our first automation, configuration management using Salt. So on Windows, we had still a big market share. But for example, the Android builds, they were not running on Windows anymore. They were migrated to Linux because on Linux we could do containers. On Linux, the Android builds could run much more parallelized. And they did not have issues like 260 char length limit for paths, because we had many, many subpaths in our builds. And usually the Android builds would fail most of the time because the path was a little bit too long. Yeah. And at that time, we also introduced the so-called pull request pipeline. That's the one pipeline to rule them all somehow. So we had, if somebody, I think you all know the concept basically, we had a big, or we still have a big monorepo. We have TeamViewer Windows, TeamViewer macOS, Android, all in one repository, which is 10 GB in size. And if you make a change in Windows, it might mean that macOS would not compile anymore, or Android would have some bugs, and so on. So what we did, we made one big pipeline, which would basically just compile Windows, Mac, Linux, Android, and so on. So in total, we had, I think, at that time, 24 jobs that were running in not such a good time, but I will get back to that in a moment. And of course, it was not as efficient as Linux, for example. Yeah. So macOS, yeah, it's gaining some traction. We have the first tools that we can use for Windows, for macOS, for Linux. That's Salt. In our case, we started with that because IT chose it's a good solution, and we were like, OK, if IT is using it, maybe we should use it too, so we can share the knowledge. Was not the best solution in the end. And for Mac, we switched to YAML Pro for a while, which seemed to be the golden standard, but was also not that good as we thought. Because we wanted to automate like everything, and in YAML, more and more things were taken out or were not possible anymore due to Apple's limitations or whatever. And yeah, macOS, of course, is used for macOS and iOS builds. And the hardware got significantly cheaper, especially with the introduction of the newer Mac Minis. Yeah, and for Linux, yeah, we have Docker. We have standardized our configuration. So basically, I went to this one Linux guy, and I asked him many, many questions. And I told him, we sit down now, and you just tell me how do you do the things? Why is this one working? And when I try it, it's not working. And he told me, yeah, there is a config file in this user directory. It needs to be there, otherwise the build will fail, and stuff like that. So basically, I just sit down with him for a while, and we figured out how to create a Docker container which will replicate what he was doing on the machines, so we could use it in our pull requests in a standardized way. And basically, we could also reduce our packages installed on a Linux machine to Git and, basically Git and Docker with some extra smaller tools. But Git and Docker was the only toolchain we needed because everything else could be done inside of a Docker container. Of course, we don't have license costs on Linux. That's a minor thing. And at that time, we also started to build a native client on Linux. So more Linux resources were needed, less Windows resources were required because we didn't have to compile it on Windows first. And we basically used Salt as our configuration manager, Zabbix as for the monitoring, and I introduced at that time also some PHP services. That's where we get back to the beginning. For example, we had our pull request pipeline, which was running all in total, all builds together. If a developer triggered the pull request, it was running for, let's say 2 to 6 hours. On average, 3 hours, which was not in a good shape, and they were quite flaky too at the same time. So developer would push the button before he went to lunch, and 3 hours later, he would return and see a failed build, and then push the button again to wait another 3 hours and continue the next day. So I wrote a tool which would exactly analyze the different steps that the pipeline takes. So basically, that's an abstraction of what Jenkins is doing. If you run a pipeline with the different stages, you will see something like this, but it's usually restricted to the last 10 builds. And if you change something in the Jenkins file, in the pipeline, then it will just throw away the old results, not display them anymore, and start with a fresh set. And what I did was, basically, I just waited for the pipelines to complete, and then transfer the build results to a separate PHP API, which would then display it in a table. Great. That's already quite nice. You can scroll down. This is restricted to the last 100 builds. And you can see the build time is already in this column. It's already a little bit better. It's not 180 on average. It's now between 30 and 40 on average already after quite some time. What we could also do with this tool was we could analyze which build is actually slowing down the pipeline. And this is sorted by build in minutes. No, total in minutes, sorry. So you can see right now Linux TeamViewer is the slowest. So we could go to the Linux guys and tell them, guys, you are slowing everybody down. Can you work on your pull request shop and make it faster? And then the Linux guys maybe would optimize something and it runs in 10 minutes. Then IoT would be next. And then we would go to Windows TeamViewer release and so on. And this is continuing forever because every team will be the slowest eventually and needs to catch up somehow. In the beginning, this was quite drastic. So some jobs, they needed 3 hours and were slowing down the whole pipeline, of course. And now it's quite fast already. And how it was optimized in total, you can actually see here. So this is the graph, the upper one, which will show you the fastest build time, the slowest build time, and the average. The slowest build time can be caused by any single build per month. So actually, it's not really relevant for us. We can focus on the average build time. And as you can see, we invested a lot of time in the beginning, almost 1 year, to bring the build times down. Our goal was 60 minutes on average. We went down below that already after a little bit more than half a year. And we could also stay there. in this region. In some months, it's a little bit better. In some months, it gets worse again. Can have many reasons. For Linux, for example, they introduced a new tool set. I think they changed the compiler, and the new one is much slower than the old one. Yeah, or Mac OS has a new version, or IT is introducing a new MS Defender scanner, and suddenly all Mac machines are 30% slower, stuff like that. Can happen. So then, oops. Let's continue. Yeah, then we also had some teams, they were using GitLab already in our company, mostly smaller teams, like single teams, and they took care of GitLab themselves. So we took care of Bitbucket, like 90% of the company was still using it. And yeah, GitLab was more like an exotic solution at that time. And we also created more Jenkins masters. For example, one specific Jenkins master just for releases. So the release managers, they didn't have to wait for the pull requests to finish before they could start like their release builds, but they had like their own executors, their own Jenkins, and also from a security perspective, of course, that's much better because they had like their own isolated environment there. Yeah. And then the present. Yeah, we started using containers on Windows as well, not Linux containers, but Windows containers with Visual Build, whatever in it, so we could basically run our whole Windows solution inside of a container. Apple has become more and more important, and whatever can run on Windows should run on whatever can run on Linux should run on Linux. That was like, yeah, basically our goal with all the services. Some were offering that they could run on Windows, but yeah, we never took that anymore. And we introduced Ansible instead of Salt. Because it has some major advantages. For Salt, I don't know if, is anybody using Salt of you or Ansible? Salt? Nobody? Ansible? Okay, some? Okay. Yeah, for Salt, you need to install an agent on each machine. The agent will connect to the master, and this can be sometimes flaky. And it makes it also quite hard to update this client. And yeah, with Ansible, you do the opposite. You connect from one machine to all the other machines via SSH. So the only tricky part is to enable SSH for Windows, and you are good to go. And of course, also take care of the user management, maybe introduce a new user for Ansible, and so on. So, and monitoring has been changed. We have the Prometheus node exporter installed on all machines. It will report to a Grafana instance, which can show us much more information than Zabbix ever could. For example, we can also include it in Bitbucket, in GitLab, and in Jenkins, and it can report job statistics and so on. And yeah, our PR builds were even got better and better over time. And because we acquired, in the meantime, some companies, they were all using GitLab. That was like somehow of a friction in the company, because now suddenly half of the company was using still Bitbucket, but the other half was using GitLab. And the decision was quite easy, especially with the new announcement of Atlassian. We move everything to GitLab because we want to stay like in our own local network. Yeah, for Windows, yeah, it's still required for Windows builds. We can virtualize like 90% of our builds now in Docker. We don't require all the tools anymore pre-installed on the machine. Before we had a Visual Studio, we had Git, we had Python, we had many other things running on the node. Now actually we only need Docker and we need Git, and that's it mostly. And there are not so many services on Windows anymore. except for a few like outliers, like our first Jenkins still runs on Windows because we never migrated it to Linux, because many paths in Jenkins are tied to Windows, and it would be like a big mess to change it. And we still have like our super old SVN server, which is running on Windows, and we don't touch that system. Ah, sure. Okay, the present, still, Mac OS. Okay. Let's jump ahead. The future, maybe. So, Windows is still required. Mac OS is using Tart now, or the teams are trying out with Tart. Tart is also similar to Docker, a virtualization solution, where you can run different Xcode versions or even different Mac OS versions, older versions, and so on. And yeah, Linux still more and more important. Cloud and AI, like our two big topics now. Cloud can be used for different tasks, and for example, we have a lot of UI tests running, running different tests in a Cypress container. Stuff like that can run in the Cypress cloud, where we can just pay some money and they can spawn 1,000 machines for us if we need to, and it will test our solution. And yeah, but there are no real changes for the rest, because our repository is quite big. Our builds take a long time, need powerful hardware, unfortunately. And we have still many dependencies inside our own network. We have Bitbucket, GitLab on-premise. We have our own storage. We have our own Artifactory, and it's not accessible from the outside. But that's something that might change with new products, or with I focus mostly on TeamViewer core, but the new products that we have, they run mostly in the cloud too, or compile in the cloud. And AI, nothing new here. We started using agents 2 months ago, actually, to try out different things. Bash, PowerShell scripts, web services in Go, client-server applications, Jenkins plugins. Basically, many things that we always wanted to do, but nobody knew exactly how to do it. So that was like a great starting point to create a first Jenkins plugin and ask the AI to do certain things for us. Yeah. That's it. Do we still have time for questions?
Thank you very much, Max. We are a bit out of time, but I think we have got time for questions. Thank you for your patience and interest, and questions.
Thanks for the talk. I was wondering, do you also test older versions, like with old Windows? This will be even more fun.
Yes, we do, because of course, most of our stuff, all of our stuff, basically runs in containers now. That was basically the purpose of the containers, because before we had a fixed version of Visual Studio installed. Now we have 100 versions of Visual Studio in containers. Okay. And if we need to test the old version from half a year ago, we just run the same container as we used to build it. Yeah.
Hey Max, thank you so much for your talk. I would have one question and one smaller question behind that. One is, like, as you started to use Adopt Ansible for the configuration rollout, how do you actually integrate the Ansible framework into your, I would say, larger landscape?
Just a moment. I want to please you to stay here, because Paula wants to tell you about the next organization steps after the questions.
Yeah. So basically, it was quite easy. We have a repository where we put all our stuff regarding Ansible. We have our playbooks. We have our one extra folder for all the additional files, like scripts or maybe some whatever configuration templates. And we have one folder for the hosts files, where we basically just have like the list of nodes that we want to include. And we have one dedicated VM where we just check it out. And this VM is like our master node for Ansible. And for the client nodes, we have one line installer that we can run on Windows, Mac, and Linux. I just created it. It's basically just downloading the script, making sure that the user exists, that the SSH key is trusted, and so on. And that's it. And then you need to go to the master node, basically, and just trust all the keys once. So it's added to the known host file. Yeah.
And as you already said, you're using SSH keys. Did you ever consider, because you have a very heterogeneous landscape, to use SSH certificates?
Not exactly. No.
Okay.
No.
Thank you very much.
One last question.
I'll try to keep it short and we can discuss later. Have you heard of or have you considered remote build execution for building on different platforms?
No.
No. Okay.
No. But I'm not too much into that. Actually, we can talk afterwards. Yeah. Okay.